Alright, I was thinking about not making a video about this, but I think it's relevant enough because, this is basically a Wein bridge oscillator I built, okay? And I'm not going to go into the details of what stupid mistakes I made on the circuit that made it not work. But anyway, but of course, one of the obvious problems with it is a fucking Wein bridge oscillator based on a light bulb. Which I actually, by the way, you might be interested in this. Um, Not this. This is another chaos circuit that only behaves chaotically for a little bit, so it's simple, but I didn't have a 100 millihenry coil, so I didn't build it, and it gets to where it's not chaotic anymore after a while, so it's, given the fact that more complicated one wasn't chaotic, period, I'm not going to bother with this either. Let's see where I put that. Yeah, Wein. I guess this is as good as any. But I did actually do a Wein bridge oscillator here. In Falstad with a little light bulb. I had to kind of trick it, but it actually does work. So, and here, let me do I'll see if I can give you a tiny URL here. Okay, so here is a tiny URL for it. I will paste it in my fucking notes if I can find them. Op amp. Okay, here's as good a place as any, I guess. Alright, so let me make the font really big so you can read it. Really? Okay, you fucking mother... son of a bitch. Okay, so, tinyurl.com 2dp17off. That's easy to type in, right? In case I don't put a link to it. But basically, anyway, that's a little oscillator for you, and it's a simulation of Falstad, and you can change the frequency by varying these resistors and so forth, and but of course it'll probably die off. I mean, again, it's kind of tricky to get this thing to work. I was lucky. Yeah, you got to have the right resistance value, I guess. What the fuck? Okay, now it just takes it a while to figure out where it's at. When you change the resistor, it'll change the amplitude, but this thing gets confused with the bulb. It's got to kind of figure out its sweet spot every time you change it. So it takes it a while to stabilize. You can try to run it at a higher rate, but it's pretty, having a hard time. But it does eventually start to oscillate. So just fair warning, if you want to play with the circuit, you may think it doesn't work at first, but give it some time. Let this thing zoom in, and stabilize. So even though I don't have the resistors matched here, you can see they're slightly different. That's 42K, and this is 39K or something. But it shows you this thing can oscillate under various conditions. But anyway, this is a real fucking circuit. So, and I fucking designed it wrong. Fucking pot. I just did it like an idiot. I'm not even going to go into it. I'm so pissed off. But but anyway, this is the only fucking light bulb I had. I didn't really have high expectations. I've always resisted wanting to build a Wein bridge oscillator because of the fact that they have a fucking light bulb in them. I've never liked that. And the fact matters, you can't just use any light bulb either. This has got way too low resistance. The bulb I've got here, but it's the only one I had on hand, and that's the result. Okay, you get a square wave. Now what's interesting about it though is it's, I've got this powered, by plus or minus 16 volts. Okay, this is like a 31 volt peak square wave. This is TL082 that I used in this. So 72 would work just fine. I imagine the 5532 would work fine too. They're all the same pin out. But but yeah, of course it doesn't work, but it does oscillate, and right now I got it at 30 kilohertz, and like I said, I can adjust it, you know, this is a capacitor bank selector. That you see here. So now we're at 5 kilohertz. Now we're at question kilohertz. Okay, we're at 540 hertz now. And now we're at 55 hertz. So, you know, hey, it's you know, it's working as this giant square wave oscillator. So, and what's different, you know, there are plenty, you know, you could use a 555 to generate a square wave, right? And of course you could stick it through a capacitor to make it AC. But if you really want a 30 volt square wave that's an AC square wave, well, you know, hey, this is the way to do it. You know, even without a light bulb. In fact, you know, it's actually very inclined to oscillate. Let me remove the light bulb. And, you know, it stops, right? And I will admit that, like I said, oscillators like this one I built, you know, with this other op amp that I did in my last video, you know, the Alta-Falstad oscillator, that sine oscillator in their op amp section that I showed you. This produces just an awesome sine wave, and it is, you know, it's 22 volts peak to peak, and it's a good looking sine wave. That's what I'm saying. Otherwise, you know, if you want a sine wave, you got to do circuits like this. You know, you can't do that with no 555. But this will work, but you've got to have the right light bulb, okay? Let's see. Let me show you something real quick. Okay. Yeah, see, here's my circuit here, and these are the capacitor banks, and that's what that rotary switch does. It, you know, it sets the capacitor bank. But let's see if I got that other circuit up here. Yeah, this one right here. Okay, this again is another great reason to try to buy Hazen's, you know, Exploring Electronic Devices book if you can find it. This is out of his book. It's a Wein bridge oscillator as well, but it's based not on a light bulb but on a CDS photocell. And I don't know if I did a video of it. I can't remember, about his little AGC, automatic gain control, which uses the same sensor, you know, but again, you can just make your own with a CDS photocell and an LED like I did. So I was going to build this version, but I'm not going to mess with it at this point, since I got this thing to actually kind of function. I'm going to hold up to, I know I got some light bulbs somewhere, but anyway, you might want to, you know, take a screenshot of this or something, you know, and build it yourself, because, you know, if you're interested in a sine wave oscillator, but you still do need a 2-gang pot preferably. But like I said, you know, you can combine this, you know, with your experiments in Falstad, you know, to see what resistor values do what and everything like that. So, you know, you could have these as independent pots and just go pot luck, right? You know, because I've always been wondering what would happen. You know, I would imagine it would make it asymmetrical, but I don't know that. I mean, it might just adjust the frequency. But at any rate, one of the big reasons I made this video is because I wanted to show you this. That in the absence of a light bulb, you can just put, you know, a resistor there. So, and then guess what? We're back in business, Theo. So, let me adjust the frequency here. So, you know, turn it up a notch. You know, so we're up to, you know, 600 or 500 or 600 hertz. But what's interesting is that, you know, with a resistor decade box, just substituting for the light bulb, I can change the frequency. So if you like a square wave generator, you know, it's a Wein bridge oscillator, and you don't have a light bulb, or your light bulb burn out, but you know that probably won't happen with a circuit like this because they never glow that hot. But still, you know, if you don't have a light bulb and you fancy the circuit, yeah, I mean, because I've buried, you know, we're up to 2.1 kilohertz now, so you know, and like I said, I just keep, you know, changing values on this thing. Oh, by the way, this is the actual original circuit. This is out of Molvino. It's one of the few circuits out of Molvino that was worth building. And it's in one of his, like problem sections. So, but yeah, it's that's what I base this design off of, basically. Um, but yeah, so I mean, it's like I said, you got pretty good adjustment. We're up to about 3 kilohertz now, and that's just the second setting. I could see if I adjust it down, our resistance is too high now. On the lowest setting, there's a certain minimal resistance each setting, because you're actually changing, the voltage drop. Since we're substituting for this light bulb here, because this is the basically this circuit here that I based this on. It's a circuit basically I built, and the same values I used, and resistance and so forth. But you're changing the reference voltage here every time I adjust this fake light bulb resistance with my decade box. So eventually the voltage gets too low and the thing kind of shuts down. So but that's its reference voltage, and it's trying to compare this, I guess, to the average voltage, between these two impedances. This is a parallel impedance and this is a series impedance. So, they're going to form a voltage divider together, and that sweet spot, is what creates the oscillation, I believe. So, there's definitely at resonant frequency, whatever that is. These are going to balance, because this is a bridge. That's why they call it a Wein bridge oscillator. Because this light bulb and this resistor are half the bridge, and this series impedance with this parallel impedance here is the other half of the bridge. And that's the reference point. Your stimulus is applied up here and down here, right? Your bridge excitation voltage, and in this case frequency, and these are your two balance points. So that's what this thing's doing, and it's trying to balance the bridge, and in so doing it oscillates. So at any rate, but because the op amp alters the stimulus in an effort to try to balance the bridge, but it can't, because it's always trying to hit a moving target. So basically it's sort of what's going on in a nutshell. But the fact of the matter is that it's still pretty cool. And then of course, in terms of maximum frequency, and I'll just make adjustments here, and go up to the maximum frequency right here. And we're at 34 kilohertz right now with the resistance I got set in here. And the lower the resistance, the lower the frequency. So we're down to 28 kilohertz or something right now. So at some point it'll probably stop. So we're at 5 kilohertz. So I mean, that's a pretty broad range. And basically I've got my resistors all turned off, so there's like 0.1 ohms or so of resistance. So that's 5 kilohertz, and then I'll go up to no, that's obviously too much. Up here it's like 14 kilohertz. So now we're at the highest frequency range, so I thought that was the highest, but no, this is the highest. This is at 91 kilohertz, at the resistance setting, and we can go down as low as like 35 kilohertz, with no resistor, in other words 0.2 ohms. But then we can go up to 203 kilohertz, and it's, remember the slew rate tests I did on the 072, we're running into the slew rate limits of it, so it's forming a triangle wave now, of sorts, because it's still pegging it, it's saturating the op amp rail to rail, kind of. So 370 kilohertz, but now it's kind of unstable. In fact, as I bring my hand near the resistor decade box, it changes. It's almost like a theremin. But you could probably make a theremin sort of out of this, That's actually pretty simple. Check this out. So like I said, let's see if I can get it both in the shot here. Woo, woo, you know, woo, whatever. Anyway, you know, the fact of the matter is that's interesting. So it's pretty noise sensitive. See, I can bring it close to the, you know, close to the wires here, and wonder if that, you know, if that could be accentuated. You know, because like I said, you know, we're clearly up there. You know, okay, it's 450 kilohertz right now, and it's 388 kilohertz right now. Yeah, if you put a you know, and put this into a nonlinear mixer, you know, with a reference signal, you could actually make a theremin of sorts with this. Yeah, it's not super sensitive, but I'll bet you could freaking accentuate that somehow. That's interesting. So, at any rate, you know, that's the guy got like a 10K, 20K. You know, you can kind of see what my box settings are right now for yourself. So it's not much. And if you put too much, it'll kill the oscillation completely. You know, I had another 30K, but that didn't seem to matter. In fact, bringing my hand next to it, you know, has more of an effect on it. But yeah, it looks like that's about the maximum range of the thing. So, you know, if you go 100K, well, I guess that doesn't make any difference either. So yeah, I guess that's its upper frequency limit, you know, around that point. You know, when I get it down to, well, we're at 0 now. And, okay, so I put 1K on it, and, you know, that's like, you know, 91 kilohertz. So, anyway, so again, I was planning just throwing this in my junk box, but, you know, I thought, yeah, I'll make a video of it, because, you know, this is actually interesting that you can get this thing, you know, to oscillate without a light bulb in it. I mean, again, it's not a good sine wave, but, you know, like it's supposed to be. But, you know, if you can't find a light bulb, you build one of these things and you break your light bulb because it's fragile, right? Well, you can still use it like this and actually adjust the frequency with this without needing a dual pot. So, you know, I just thought that was interesting that you can kind of do that. So, you know, I thought it was worth making a video about because of that. So, anyway, you know, I guess that's about all there is to say about that. So, cheers. Oh, and one last thing I forgot to mention is that, you know, I do actually have light bulbs somewhere. You know, I took it off of an old strip chart recorder from the 80s that I bought in Silicon Valley when I was down there at one of their junk shops. But at any rate, yeah, it had like some little bitty light bulbs in it to light up the chart, you know, which are low voltage bulbs. I think like 5-volt bulbs. They're little tiny bulbs. I don't know what I did with them, but I think they might be perfect for this, you know, this, not this circuit, but this, you know, Wein bridge oscillator. So, you know, again, I'm going to keep it around, you know, until I find them. Cause I know I didn't throw them away. I still got them somewhere. So, you know, I might make a follow-up video if I ever locate them. But they might actually work, and so I might be able to actually get this thing to work like it's supposed to by putting a light bulb in it. But that's what's great, you know, because you could actually build one of these with a light bulb in it and have it be a sine wave generator, you know, but then convert it over to light bulbs, okay, and make it a, I mean, you know, to convert it, you know, put a light bulb in it and have it be a sine wave generator, you know, but you'll need a dual pot if you want to adjust the frequency that way. But then switch it over to a square wave generator, you know, and vary it based, you know, on this decade box, or, you know, or a potentiometer you stick in there instead of the light bulb. So, you know, it makes it a versatile oscillator. And again, you can't really do that with a 555, you know, is what I was kind of alluding to, you know, because it generates a DC square wave, not an AC square wave. So that's what's interesting. Now, there's certainly some ring in it, like you saw, but at any rate, you know, another thing that brings to mind, you know, about the strip chart recorder is that was an awesome little find, because there were some interesting parts in there, including like 30, you know, mercury wetted relays. So, and if you know anything about those, even ESP guy talks about them in his relay section. Apparently, since mercury weighted relays don't have any switch mounts to them, you can actually make a picosecond, um, you know, uh, basically a stimulus waveform, a transitional waveform to like test op amp, step responses and things like that. So, because you think about it, yeah, you just kind of hook it to a voltage source. You just, in a resistor, you just switch that in and out. But supposedly that could switch really fast, because there's no switch mounts. So, that's like I said, I got like 30 of those fucking things. So, that was quite a find. So, but anyway, if you ever come across any mercury roulette relays on eBay or something like that, well, that's one use for them. You can make a step response. Because they're basically read relays, basically, but they have mercury in them. So that they can actually switch. But not a lot of mercury, but enough to where there's no contact mounts. So, yeah, but ESP guy actually did some tests on. He's got a whole article written about relays, a couple really. Um, but he mentioned that in there, so I thought that was fascinating because otherwise I wasn't really sure what to use those for. But yeah, that was a good idea. So but yeah, if you ever come across any of those, you can make a low frequency, because it is a relay, keep that in mind, but make a low frequency square wave generator, for example, that has really sharp transitions on it, more so, way better so than you might be able to generate with most electronics means. So crisp, clean square waves. So anyway, just thought I'd add that.